Well, look, first of all, I'd like to welcome everybody to this presentation. Just introducing our speaker today, John. It's going to be a most interesting presentation, I'm sure. I first met John in 2003, and over many years since then, I've been in touch with him through RN contemporaries from Submarines or Manadon, and in more recent years with John and his wife with the Naval Officers Club. So you've seen his CV there. Welcome to you all. And John, we look very forward to your presentation. Thank you.
Thank you, first of all, to the Naval Historical Society and David Michael for inviting me to make the presentation, to Noel and Doug for enabling it to happen, and to David Blasey for his introduction. We've known each other for a long time, on and off. So I became a submariner, and that's a rather select group of people, but still naval. I'm going to talk about something which I think is very topical. It's and will be seen in retrospect as an historic event. And I'm just going to unpack it a bit, because previous presentations we hadn't had the AUKUS announcement, so I've added that at the beginning. So there's a fair amount to talk about, and I hope it's in a logical sequence. I was going to talk about HMS Astute because in my time in the Navy, Royal Navy, as an engineer, after finishing sea time, I went into engineering headquarters in Bath, and my last job there became engaged with the Astute project. It wasn't called that at the time. On the bottom left, you can see the topics I'm going to cover, which I think are in a logical sequence, and if they're not, you can tell me afterwards. So in my time in engineering headquarters, I became involved with the Astute. My last job there was as the head of the design section for a future propulsion plant. This is not the reactor, it's what you do with the steam once it comes out of the reactor. We were finishing off a revolutionary new design, increasing the power and make it smaller. Already, submarine equipments are about 1/3 the density. The density is 3 times higher than it is on a surface ship. So here was a raft which stretched the full width of the submarine hull. All equipments on board a submarine are noise mounted to prevent transmission of noise to the outside, and also shock mounted, because if you get weapons thrown at you, the equipment has got to survive. A big raft, 2 steam turbines on the middle, feeding into double reduction gearing out to a propeller shaft. Outside them, and using the same condensers, were 2 turbo alternators of about 6 megawatts. Because the nuclear submarine's got plenty of energy, it's actually a power station as well. There are 5 different electrical systems on board, and the turbo alternators produce the AC, high power. The raft went on test, the first one, in 1982, and the first of class, HMS Astute, was commissioned in 2010. So you can see there's a bit of lead time. The next job I had was in London on the naval staff. We were invited to study the concept for the next class of submarine and come forward with some options, proposals as to what could be done. It was called the Batch 2 Trafalgar class at that stage, because we were going to improve the Trafalgar class, get rid of the things we didn't like in it, include the new things such as the 2nd generation nuclear plant, PWR2, and the propulsion package, which I've just talked about. The interesting bit of the concept study was, however, we were looking ahead to see what the Soviet Navy would have at sea as surface ships and submarines, which would be competitors to the submarine. There were 2 ways of attacking this. One was you went to the naval intelligence and said, hey, what are they doing with Soviet ships? What are they going to be like out to 2030? What are they working on? And the next leg, even more interesting, was to go to open source literature, Russian, produced by scientific and other bodies, which showed the sorts of things that they were interested in, and to see if any of them were relevant to nuclear submarines. There were a couple which looked at, but none of them came, we didn't think that they were going to be a problem. Coming to the area here, Southeast Asia, it's rapidly becoming a center of gravity, political, commercial, and military, which is causing problems. The military expenditure in the region has gone up by 50% in the last 10 years. The US fleet, which dominates the Pacific at the moment, is projected to have between 321 and 372 ships, depending on how much money Congress is going to give them. In the meantime, the Chinese Navy, People's Liberation Army brackets Navy, has 355 ships at present, and they are on what one military analyst described as a building spree. They're going to have 460 by the year 2030. China is now a maritime power. We have to recognize that. They're building what is called a far seas navy, what we'd call a blue water navy. They have, for example, already got and had for 6 years deployment to the Arabian Gulf, 10,000 kilometers from home, ships on permanent deployment for up to 120 days at a time. It's on anti-piracy primarily, but they've been doing a lot of other work, learning to work with other nations, humanitarian aid. And also, if you think about it from the Chinese point of view, a lot of their trade is by sea. Particularly, you think of the oil that comes into China. Their sea lanes are long, and they're worried about interdiction by opposing forces, particularly things like the Malacca Strait. So it's a maritime power. We shouldn't, however, forget why the Martello Tower, Fort Denison in Sydney Harbour, was built. That was a concern about Russian invasion. The Russian Pacific Fleet, the second most important fleet, is not large. It doesn't have too many new nuclear submarines, but the ones it does have are very technically advanced, and the number is slowly growing. The other thing is, out of the AUKUS alliance, at the end, the Chinese Premier, Xi Jinping, declared that Australia is now an adversary. We're no longer solely a trading partner. So our region is becoming increasingly important. And Australia sits geographically at the pivot point between the Indian and Pacific region. I am not mentioning Antarctica, which is another subject which could be discussed. The distances, you can see, are quite large. In other words, we're talking about operating over large sea areas. Who do we have on our supporters bench? Well, the US, a few years ago, declared a pivot from worrying about Europe and the Atlantic to worrying about China and the Pacific. One of the first on the ground outcomes of that, I think, is this AUKUS alliance, which has just been announced. The other one is the UK. UK withdrew all forces east of Suez in 1976. They turned its back as a result of joining the EU on Australia. However, last year they had a defence review, and they've done what they call a tilt. This picture shows 9 ships in the Carrier Strategic Group 21, which has just completed a 26-week Far East deployment. There are 10 ships in this group. One of them was a submarine, Hms Astute. But you'll only see 9 in the picture, and you can work out why. France has been a bit upset with Australia, but I think it's worth remembering that Polynesia is an area of 5 island chains, the size of Europe in the middle of the Pacific, with 2 million French citizens. They're not colonies, they're direct citizens of France. Last year, a Rubis-class submarine, Emeraude, deployed to the Far East and visited Australia. The Defence Strategic Update last year pointed out the fact that the regional strategic environment is deteriorating. It sets out for naval forces the area of operation, for long-range frontline defence, again, distances, and a role of the Australian Navy is deterrence. Stop aggression against Australian interests. The naval forces need to be able to project powerful force, and of course, defence, the best defence is being prepared for attack. While not engaged in hostilities, it's very important gathering intelligence so that you know what's going on, where it's going on, and in other words, know your enemy. Submarines are not so good at area denial because you can't see them. The Americans have been sailing carrier groups around Taiwan, demonstrating that international waters can be used by everybody. What submarines do have, though, is a force multiplication effect. Because they dived, nobody knows exactly where they are, and an opponent has to recognize they could be in more than one place at the same time. Force multiplication. I want to talk briefly now about the AUKUS Alliance Initiative. The AUKUS Alliance is about technology generally, but the first initiative is the acquisition announced by the 3 US, UK presidents and our Prime Minister on the 16th of September. The acquisition by Australia of 8 SSNs, this is nuclear powered, but with conventional weapons, and that's been stressed. It's nothing to do with nuclear weapons. The AUKUS Alliance Initiative options, they're offering 2 mature classes which are currently in build in US and UK. These are the latest class of submarine, which is still being built. How will that all be achieved, they say, is a technology transfer. What that will be, we don't know yet. Vice Admiral Mead is with a task force studying how and what will be done. We're told that all the submarines were built in Australia, and there is the Australian Submarine Corporation facility in Osborne, South Australia, which presumably will be the site of the building. Ideally, the nuclear submarines would be available as the Collins class retire, but that is going to be a big ask. So, what's this fuss about nuclear? I mean, well, the first thing is air independent. It's a nuclear process, not a chemical one. It depends upon the splitting of uranium-235, not the burning of fossil fuels. The other second important thing is that energy density. 1 kilogram of diesel fuel, about 1.1 litres, if you can imagine that, has roughly 45 megajoules of energy in it, if you could get it all out. 1 kilogram of uranium-235, which is uranium, which is enriched only by 10% uranium-235, which is the fissile isotope, which is roughly the size of a mandarin, has 14 million megajoules. So there's a bit of energy to spare. Imagine going into a car dealership and the salesman comes across to you and says, I'd like to show you the latest model. This model of car or vehicle has all the fuel in it already on board for the next 30 years. Not only that, it's under the bonnet. It eats inside the engine. That's nuclear energy. However, Mother Nature doesn't give you something for nothing. And the consequence of splitting uranium-235 is you get fission products, not a large quantity, and they can be retained within the fuel, but they are highly radioactive and must be prevented from reaching the atmosphere because of the potential damage. The other problem is that the fission products themselves are not stable. They decay away, releasing further radioactivity and heat, called decay heat. Even when the reactor is shut down, the fission products are producing heat. So from the day that the reactor first goes critical to the final last day when the fuel is removed, there must be core cooling to remove the decay heat. A quick reminder, I know, I hope I'm not insulting people. Anyway, a thermal neutron at the top here, traveling slowly by neutron standards, only doing about 2 kilometers a second, is absorbed by uranium-235. 236 is unstable and splits into two roughly equal halves, a pair. There are lots and lots of different pairs. In this particular process, a great deal of energy, as in all fission events, occurs, and this particular pair produce 3 fast neutrons. Now, the skill of the reactor designer is to make sure that one of these is retained, slowed down, which in a pressurized water reactor, call it moderating, it's slowed down by the coolant, water, so that it is available again to continue the fission process. What are the roles and platform capabilities? Well, SSN roles. For me, this is an opinion, the most demanding role is attacking other submarines. In a hostile environment with no supporting forces around you, you do this with wire-guided torpedo. I think it is the one for which the submarine needs to be optimized as far as possible. However, an SSN is a multi-role vehicle, and it can attack surface ships with cruise missiles, land attack with other cruise missiles, all fired from torpedo tubes, and there are an increasing range of missiles, various capabilities. There are other lesser roles like laying mines and things, but these are the main ones. When not engaged in hostilities, its task is to gather covertly, by stealth, information about potential opponents, preferably in their front yard, so you know what's going on. The platform capability, by platform I think you understand I'm talking about the submarine without the weapons and sensors, the combat system. An SSN provides an ideal platform which allows the combat system to be used to its maximum capability. The other thing about SSNs is extended patrols. The submarine materially can stay on patrol for as long as you want. Normally you say 90 days because for 2 reasons. One is the fact that you've got to carry enough food to go further than 90 days. And the second thing is the crew can't stay out forever. They need to get back to base for various reasons, not least school holidays. The other thing about an SSN, it's got long legs. It can travel at sustained high speed for long periods and get where it wants to go with a minimum delay. However, I'll talk a bit more about speed in a moment. The most important thing, and the quality of a submarine, which is most important, the one where there's competition between the various navies, is quietness. Quietness provides a submarine with a characteristic of stealth, the ability to avoid detection. The other main reason for being quiet is to allow covert attack on enemy submarines. The ideal is where you approach to within a few thousand meters, and without your opponent, without the target being aware of it, you can launch a torpedo against him. If you get into a dogfight, you do not get any marks for coming second. These are the 2 latest ships in each of the classes. They are on the surface, they're not in their optimum designed environment, which is underwater, the 4th military environment. However, it gives me a chance to show you. This is the Astute class. The sonar sets, big sensors, an active and passive sonar, very, very rarely used active, because the minute you go active, you give yourself away. Down the side, you've got 2 large flank arrays. Yeah. And then the most useful one for low long range, and I'm talking thousands of kilometers, is a reelable towed array. This is a wire with sonar transducers picking up low frequency noise. Radar doesn't work underwater, so all detection, classification, and attack is done using sound. In deep water, there is this sound channel which can allow you to pick up sound, low frequency, thousands of kilometers away. As you get into shallow water, you get bottom bounce as well, which complicates it. And this shows a uniform water body. Well, it doesn't actually happen, particularly close to the coast or in currents. Seawater is not uniform. It can come in layers of temperature and salinity, and the speed of sound varies depending on the salinity and the temperature. So you get both reflection and deviation of the sound track by these layers, and a commanding officer submarine needs to know where they are and what the sound is going to do, because it can allow him either to hide or better detect opponents. A quick run around the Astute class. Up forward, back aft, you've got 2 ballast tanks full of water. You blow them out with high pressure air, submarine comes to the surface. These are hydroplanes, forward and aft. They're used for flying the submarine. At any reasonable speed, they provide lift and very quickly all to depth. Up forward, you've got administration. You've got the ship's office where minor things like mail, ship's company mail, stores, spare gear. Next, you have communications office, all the radio sets. You've got satellite radio, HF, MF, electronic countermeasures, ECM. That is, you've got a radar set for navigation, but you're normally using it to detect other vessels looking for you with radar. And then you've got the sound room, the most important, you could argue. All the sonar sets here receiving the signals from the various sensors, transmitting information to the control room. The control room here, underneath the fin, has 2 officers of the watch. There's 1 officer of the watch fighting the submarine. And the second one is ship control officer of the watch, managing the way that the systems on board operate, non-nuclear. These are optronic masts. No longer do you have periscopes and things penetrating the hull. They're all optronic. The signals are transmitted down to the control room. On the middle deck, you've got bunk spaces, mess decks, galley, bathrooms. And down below, you've got tanks, storerooms, most important, HP air compressor, oxygen generator, electrolyzing water, and CO2 absorbing equipment to take the CO2 out of the atmosphere. Back aft here, back aft you've got 2 large bulkheads, heavy bulkheads, lead lined, and within it is the reactor compartment. The reactor, quick run round. Pressurized water reactor. The reactor itself is fuel, a primary circuit, water pumped at high speed with a powerful variable speed motor, a heater which pressurizes the water so that this water primary circuit does not boil. The water is passed to a steam generator where there is, again, pure water, very pure, which does boil, and that produces steam which is led aft to the steam propulsion plant. A quick run around the reactor. The core is fuel rods inserted here. Water passes up past them, removing the energy. Control rods, these are neutron poisons, which mop up neutrons, and you raise and lower them to alter the neutron flux within the core, which determines the power that the reactor puts out. This shows a whole lot of joints and things in here. It's not an actual submarine one, it's an illustration. But all the joints in a submarine one are actually sealed because it's a containment boundary, one of the 4 boundaries that helps to stop fission products getting out. Back to the submarine. Well, aft here is the maneuvering room, engine officer the watch, and the maneuvering room crew operating the reactor, the switchboard for the control systems for the electrical, and the propulsion with the main engine throttles. On this level here, you've got switchboards, electronics, air conditioning equipment, and most importantly, 2 diesel generators. Now, they are emergency equipment. If the reactor shuts down, scrams it's called, which doesn't often happen, and usually scrams are done because I would wander aft and without warning, unalerted drill, you'd scram the reactor and watch to make sure that the watchkeepers performed correctly. The diesel generator is required because if the reactor scrams and you can't get it back within an hour, the battery is supplying the propulsion motor here, supplying coolant for the reactor, providing power for the combat system and domestics, although at a reduced level. If you have to run the diesel, it means you've got to come up to periscope depth, raise a snort mast with a float in the top, radar mast, ECM mast, periscopes, all of which gives a detection opportunity. And in rough weather, it's hard going for the control officer of the watch in the control room to keep the depth correct. If you go down, the float valve shuts, the diesels are running at 100% power, pumping air out of the submarine. And until you come back to the surface again, towards the surface, that air is not replaced. On the steam plant, back aft the next compartment, the diagram on the right, you've got 2 steam turbines mounted on a raft, driving double reduction gearing onto a propulsor. It shows here a propeller. A propulsor is just a simple water turbine, but it's quieter and more efficient than a propeller. There are turbo alternators, which produce the AC, high power, and conversion machinery because you've got a battery and you've got to have DC. As I said, 5 different electrical systems on board. Right, difference between the 2 classes. Well, the Astute class is a bit smaller, but the most important thing was the length. One of the objectives of our secondary propulsion design, steam plant, was to shorten it in while increasing the power. The length of the submarine now is approaching the optimum for hydrodynamic propulsion through the water, the minimum power required for any particular speed. The interesting thing is that we did increase the hull diameter slightly, and that is a big difference between the 2. And the reason for that was to get the secondary package in, it was tight. But to get it shorter, you needed to put this package, squeeze it up. The other reason for increasing the diameter was that we wanted to put 6 torpedo tubes into the submarine as opposed to 5 in Trafalgar class, which gave us the option then of good weapon stowage of 38 reloads. The Virginia class has 4 torpedo tubes and 38 reloads, but it has got 12 vertical launch cruise missile silos. The reactor power, well, the reactor power is less in the Astute class. You'll notice the speed, it can still achieve a very high speed. And I come to this point that once you get to the mid-20 knots, depending on the design of the hull, you begin to create such turbulence in the flow around the hull, it causes noise. Noise is both a giveaway for somebody looking for you, and also it impairs the effectiveness of your own sonar. So high speed is not necessarily good news. In all my time at sea, only once did we travel at high speed. We came out of Gibraltar on a return from a patrol, turned right to go back to UK, and got a flash signal from Northwood, the fleet control, and said, there is a Russian ship in the middle of the Atlantic. We want to know what he's doing. Get there. So we went deep, wound on full power for 30 odd hours, scaring all the whales, absolutely blind and deaf, to find out what was happening. Reactor life. Well, you see the Virginia class, they're talking about 33 years, 25 for the Astute, not because I think it's going to be that short, but because they haven't been running long enough. I mean, it probably will be 30 years plus. The crew, one of the said that we wanted to shorten the submarine in. Well, one of the clues is up forward, as opposed to aft. You reduce the number of people. It reduces, if you take out one sonar set, you reduce the number of operators by 2 or 3, depending on 2 or 3 watches. Fewer bunks, smaller mess decks, less food, smaller galley. It's a virtuous circle. What if you can reduce the people? The cost. This is the cost of the last 2 in each class. But I thought about comparing them directly, but they're in different years, different currencies, and I thought perhaps you could try that. The submarine task force under Vice Admiral Mead has got 18 months to look at how the project is going to work. So we don't have any plans or timescales. But just quickly, the sorts of things that are going to happen is a technology transfer. Well, that is what is going to be transferred. My preference would be for an Astute class platform with an American weapons system, combat system. And because of the way the submarines are designed these days, I think the Americans call it open architecture, and in UK we used to call it fit for but not with. You don't need to decide on the web combat system until well on in the design of the submarine, which allows you to pick up the latest improvements in weapons and sensors. The design office. Well, I know Collins class and the attack submarine class have got design offices, but I think the task of the SSN is going to be an even greater design task requirement. They're going to oversee the building of the submarine, and this is the facility in Osborne, which presumably will be the right size for building nuclear submarines. If you want to know what it's like building a 7,000-ton Swiss watch, then there is a very good YouTube video. All you do is Google HMS Astute building and BAE, because BAE was the company that built it. In parallel with the design office, of course, because the submarines are going to be indigenous, they're going to be an Australian design, built and supported in Australia, there will be need for a headquarters design, a support organisation. That'll be separate from the design office. Also, because it's nuclear industry, there will be a need for an Australian generation of companies which are capable of providing equipments and systems up to nuclear standards. That will be a big task, won't happen immediately, but I think it would be a fantastic thing if at the end of the building these submarines, Australia has the ability to build its own submarines and support them. That would be incredible. There is an interesting thing, and that is nuclear safety is not a problem on building, because not until the very end of the building process do you test the reactor. It's called power range testing. You take it up to full power, and that's when you give it a license. That particular reactor gets a license to work. There are very few fission products in there, so nuclear safety is not really a problem. There are still precautions. However, at the end of a submarine's life, there will be 30 years of fission products in the fuel. They need to be removed, and for that you will need a facility that has full nuclear safety facilities preventing the release of the fission products. HMS Sterling operates submarines already, the Collins class. Just a quick couple of things about, there's a nuclear cleared berth there already. HMS Astute was there at the end of October, about the 26th, I think. They'll probably need at least another cleared berth. The other thing is, periodically, the submarine has to be lifted out of the water to clear anti-fouling, and also it's covered with anechoic tiles, that is, tiles which reduce the reflection of active sonars as a protection. Also, any other underwater work on a propulsor or ship fittings. This will be a nuclear ship lift, it's not just an ordinary one. Also, nuclear workshop. The maintenance and repairs for the nuclear plant will probably be quite small, but it does require people with the skill to do things like stainless steel nuclear welding. In Scotland, the naval base there, they have 2 simulators. One is for training and requalification of nuclear propulsion plant operators. One of the things you have to do is to learn and practice emergency drills. You can't do that on a real submarine, so you have a maneuvering room simulator. Also, there's a ship control officer of the watch where his team of people practice what's to be done. Nuclear safety, quite rightly, a lot of people are worried about nuclear safety. And I think the figure to look at is here. It's out of date because this is the US only and only to 2019. But it does show that in all these reactor years, there hasn't been a single nuclear accident by the US, UK, or French navies. The other thing is, I said, you've got to prevent fission products reaching the atmosphere. The design requirement for commercial plants, for which naval ones are similar, is 1 fission product release event per million reactor operating years. Quite a demanding requirement. You have to design for it. In Australia, nuclear safety regulators required already because the Australian Reactor Radiological Protection and Nuclear Safety Authority exists because there is a nuclear reactor operating, Opal reactor operating at Lucas Heights in Sydney. This regulator will need another branch looking after the Australian Navy. Inside the Australian Navy, there will need to be some authority, I've called directorate, I don't know what it would be. 3 basic tasks. 1, to specify the training for the reactor operator, plant operators. 2, to carry out audits. Any body, any authority, ship build, base, building, or on the submarines who operate nuclear plants are periodically audited. And the 3rd most important one is incident reports. That is where, for any reason, due to material or personal failure, the level of safety is degraded, it's reported. No names, no pactoral. It is analysed and the cause is removed. How is nuclear safety achieved? Well, the first thing is to design it and demonstrate to the satisfaction of the safety people with a justification saying this is safe and it's accepted. The next thing is you've got to build and maintain and operate the submarine to achieve the design. And for that, one of the major tools is full quality assurance, right down to the last nut and bolt provided by the corner store. Everybody, full quality assurance. All the civilian manpower involved, and there's a big tail, as there is for automotive, a very big tail for nuclear. Anybody who has nuclear activities which could affect safety need to be trained and qualified to the appropriate level. And of course, the naval manpower needs training on plant operations and refresher training. So I think for Australia, this project is a major challenge. It will, however, create a weapons system with a component for deterrence, which is will upgrade the capability of the Royal Australian Navy, not only for this class, but one assumes that subsequent classes will be designed and built in Australia as well. In other words, an ongoing major enhancement to naval capability. For shipbuilding, submarine shipbuilding, it'll be the rejuvenation of the building industry. And again, I would suggest it's a continuing one. There will be no stop-go. There will need to be a continuous build of nuclear submarines. Not only this class, but subsequent classes as well, which is good because you learn as you design each class and you build on your previous knowledge. For industry, a large number of companies will need to be qualified to supply design, test equipment to be used in the submarines. That will be an ongoing, continuing process. So I think it is not something, again, this project is not something that's going to happen overnight. It can take 20 years. But when you realize that the Indians, who are no slouches for engineering, took over 40 years without technology assistance, although they did lease a Russian submarine, it took them over 40 years to design and build their first nuclear submarine, Ariane. So to do it in 20 years for us will be a major achievement. It'll be an historic achievement, I believe. In engineering terms, it'll stand alongside the Sydney Harbour Bridge and the Snowy Mountain scheme. So all I can say is good luck. I showed you the Carrier Strike Group 21, 9 ships on the surface. And of course, this is where the 10th one, HMS Astute, was, because she's died. Okay, that's it. Do you have any questions? And thank you very much for listening.
What chance do you think there will be of attracting both engineering and other nuclear submariners from the UK to come and join the RAN, as has happened in the past when we've got into new areas of capability?
Chris, that's a good question. I think there will be a need for a build-up of the Australian submarine community, and the engineering staff will go through for training. That will be an attractive option professionally. I mean, it's a challenging task, but I think Australia is such an attractive place to live that I think Europe is going to become increasingly difficult. UK, difficult. My son lives there. And I think, like us, when I retired, moved to Australia, I think it'll be good, but it will not be sufficient. I think one of the things that I think I've been on about, and you know about, I think there's a desperate need for a civil nuclear industry, because when in the RN, Royal Navy, and in the US Navy, people leave the service after their nuclear time in mid-career. And to go into civil nuclear power is good for the civil nuclear power, and it's ideal for them. Otherwise, what do they do with all their experience they've gained? But yes, I think the prospects are good.
I've got a question, John, if that's okay. One of the problems with the Collins now is getting adequate crew numbers, and that's going to obviously affect the capability. If we're going to get 8 bigger boats with bigger crews, how do we tackle the problem of getting the manpower, or should I say person power?
That's a good question. I think that there are various ways. I mean, the prestige of working in a nuclear submarine was the same for the RN. You know, we had to apply. We weren't automatically accepted. But that isn't sufficient. I think there may be. We didn't get extra pay for being nuclear engineers in the RN. And maybe if you want the people, you're going to have to pay on top.
Great.
I don't know. But you'll need the people, yes. I've even scared the horses, as Jock Thompson said, when I wrote an article for the Naval Officers Club newsletter. I think that this is going to be such a powerful deterrent weapon system. It should be out on patrol all the time, as much as possible. Now, I've worked in a system where one nuclear submarine had 1 crew, and it was hard going because the amount of time you spend at sea. The SSBNs in the UK, and I think the US as well, have 2 crews. You alternate crews. So one option would be to chat up the Philippines or Indonesians perhaps eventually, have a forward base, and you just change over the crew.
John, myself, I've found on watches fatigue, etc. Is there an hour, 2 hours, 3 hours watch annually or generally per day?
You mean the watch-keeping system on board?
Yes.
Well, the one we were using in SSNs, which were quite heavily worked, the seamen moved into 2-watch system, 84 hours watch-keeping a week before departmental duties. That meant that they were doing 6 hours on, 6 hours off.
Okay.
With the two fully qualified nuclear submarine commanding officers take it in turns. So you always had a watch on deck
Yes.
that could put a weapon into the water within seconds, because if you heard a torpedo coming towards you, it's no good then shaking the captain. So they were fully competent. Back aft, the engineering instructions in the Royal Navy is you may not work engineers at more than 1 in or less than 1 in 3, because lessons have been learnt as accidents. So it's 4 hours on per watch, 1 in 3. And when I got people qualified coming across the Indian Ocean, when we did a 9-month deployment, I managed to have 8 engineers qualified to watch keeping the manoeuvring room. And that was luxury.
Yes, easy. Thank you. Thank you.
John, it's Neil Westphalen here. I have a question regarding the time frame it takes from to produce nuclear engineers, starting from a newbie that has no engineering background and taking them through to becoming a fully qualified
Supervisor.
engineering. We'll start with engineering officer of the watch. And how many? So how long does that take, and how many nuclear qualified engineers do you actually need per boat?
Well, it depends upon the number of crew. I mean, when I was on nuclear submarines, they were attack submarines, not SSBNs. We had 1 crew. I was the engineer.
Yeah.
So it meant that I was on all the time. My wife complained that the black pig was actually the wife and she was number 2. How long does it take? In the Royal Navy, when I was in the system, writing the requirements, you took an engineer officer who'd been in the Navy for 5 years. He got an engineering degree, mechanical engineering or something appropriate. You then put him through a 9-month theoretical course at Greenwich, which we taught the systems, but they were learning nuclear physics, chemistry, metallurgy, and all the other things. Then sent them off to a simulator, or in those days you had a shore-based prototype, and they used to qualify on the prototype. They then have up to 6 months on board the ship to go through and qualify in all the nuclear watchkeeping positions, from the motor room, EM upwards, ending up with a simulator test, an interview, a stress interview, I might say, which is a bit unkind, but you let the chap dig himself into a hole and then tell him he's got himself into a hole and how's he going to get out of it. And if they break down, you don't want them in charge of your reactor. So it takes about something like, I don't know, 18 months.
Okay. And the other question, sorry if I may, is you're talking about the simulator. I understand the need for a simulator facility ashore. Would that mean, would that actually be entail using an actual reactor, or would it just be a simulated reactor?
No, it was built by Ferranti and programmed by Ferranti. We gave them all the nuclear physics equations and things, and they set it up and said, this is it. And but when you went in there, discovered it didn't behave, the watchkeepers could say, this isn't like my submarine, it doesn't behave the same way. And they're very interesting. First of all, the equations are average equations, and they had to tweak them. The second thing is each nuclear plant, depending on the life of the core and other quirks, is unique. So you had a sort of switch, and you could switch it to HMS Superb or whatever the reactor was.
Right.
And then at the end of the day, you still had lookup tables. You couldn't do the calculations. You went down, measured it on the submarine, recorded as a lookup table, and took it off to the simulator.
So you don't need so what you're saying is, just to be clear, you don't actually need to have an actual live nuclear reactor to act as to provide the training on a shore.
No, well, you can't, because what you're doing is complete loss of flow accident. You practice because it's one of the things you're supposed to learn. You can't do that for real.
Yeah, no, I understand that. That's fine. Thank you very much.
Just a question from Australia, from New Zealand, Auckland, New Zealand. Tony Lewis, has there been any public reaction in Australia?
Well, other people, I'm amazed how little reaction there was. I don't. Anybody else wants to comment on that?
There is a very vocal minority who are implacably opposed to anything nuclear. And this was in evidence earlier this week at a hearing of the Joint Parliamentary Committee on Treaties, where one of the Labor Party members of the committee got all worked up about the fact that because both the US and the UK reactors that are proposed use highly enriched uranium, which is why they can last for 30 years without having to refuel, that puts Australia in violation of the Non-Proliferation Treaty and or other provisions required by the International Atomic Energy Agency. This is strongly disputed, including by some Labor Party members. Gareth Evans, for example, is on record saying that that isn't the case, but there's public reaction all right from this vocal minority, I can assure you.
But I think you're right, Chris. It's a minority, but this point has to be tested. My personal belief, having been involved with reactor core design, is that it would be possible to build a longer life LEU. Depends upon what the degree of enrichment is, but I think it would be possible to build fuel. But of course, that won't be available to start with. But it's something that perhaps we should be researching right now in Australia to get out of this potential dilemma or problem.
And has there been any talk in Australia yet about the civil? You mentioned the civil side of things. Has there been any statements from the political scene about creating a civil nuclear industry or civil nuclear power in Australia?
Chris, do you want to say a few words?
Yes, thank you for the invitation to make these comments. I've been looking into this for quite a while, as John knows. The bipartisan support for the AUKUS agreement, and most importantly, the nuclear submarines as part of that, came with three conditions. And one of them was that it does not depend on creation of a nuclear industry for general power generation and so on. They are very strongly opposed to a nuclear industry, even though there is a growing body of people, including the former chief scientist, Dr. Alan Finkel, who say that we will never get to a satisfactory electric power grid with renewables only, that there will need to be some other more predictable and reliable source, and nuclear would be an obvious choice. End of comment.
Thank you, Chris. I think I would just like to dive in a bit and say, Professor Stephen Wilson recently, his students produced a paper saying, what are the stoppers, what are the hurdles that would stop civil nuclear power being introduced into Australia? And his conclusion basically was that there's no technical reasons. There are two hurdles. One is the requirement to raise the legislative bands in Queensland, New South Wales, Victoria and federal. And the second is public opinion. And of course, the two are related to each other. You're not going to get the politicians saying we'll go for nuclear until they believe the public's on their side. The public who don't know about it or haven't been briefed about it aren't going to be happy about it until somebody starts talking about it.
Yes, well, I find it very interesting that the civil reaction, and you touches on what you just said, has been so muted in Australia. I find that incredible from this side of the Tasman.
Well, what's it like in New Zealand? I think it's pretty...
It's anti-nuclear.
Yeah.
It's incredible. Yes, absolutely.
Well, when I was out here in HMS Warspite on deployment in 1973, we were not allowed to visit Australia or New Zealand.
Just one other comment about the political approach. When you get the leader of the Greens saying if we get 8 nuclear submarines, we're going to have 8 underwater Chernobyls. So we won't convince the Greens, but there needs to be a huge education program, surely, and that needs to be started pretty soon.
I agree with you entirely. I think comments like that are risible, I think is the polite word. It's based upon ignorance. But you won't get people saying they don't follow it or don't believe it until there's education. How do you start education? I don't know. I was asking my grandson, senior grandson, the other day, in physics at school, I mean, when they do science technology, do they talk about nuclear physics at all? And he said, yes, they do. They talk about atoms and neutrons and all that sort of stuff. So there is some education.
John, from your own knowledge and your research of the Russian experience and so on, and probably lots of other sources, could you speak a little bit more about the 1 in 1 million reactor hours? What form could such an accident take, and how is it already prevented? You mentioned at one stage, you were talking about the reactor of 4 containment zones, for example. And I know that the ARPANZA rules for visit by nuclear powered warships to Australia rely on the fact that both the reactor containment vessel and the pressure hull of the submarine provide 2 concentric containments. But could you expand on that from your engineering knowledge of, you know, if and when the accident does occur, how it will be mitigated, please?
Okay, thank you. Good question. During one of the things, looking at reactor design, engineering design, one of the things we started off is backwards. The nuclear industry is the only one where they've designed an accident and you make sure it doesn't happen. An instantaneous complete loss of flow, in other words, complete loss of cooling at 100% power with maximum fission products. That's your accident. And we used to call it was called then, I think, maximum design accident. That's the starting point. What happens, first of all, how did you get there? And what you do is a fault tree analysis to show all the possible paths that lead there and make sure there are barriers down each path. That's part of the nuclear training, administration, design, quality assurance, and so on. The other part of your question is, what happens if and when you have an accident? The submarine, you assume, is in the presence of the public, because if it's at sea, people aren't quite so worried about it, apart from those on board. What you do is, there are 4 barriers. One is the fuel cladding itself, and every day you monitor the primary coolant and see if the activity, amongst other things, if the activity's gone up. The second thing is the primary circuit is a completely sealed boundary, including the pumps. That's the second physical barrier. The third physical barrier is the reactor bulkheads, forward and aft, which have got penetration through them. And after that, if it gets out through the reactor bulkheads, you've got the whole of the rest of the submarine, which you can shut down because it's deemed to be fairly watertight normally. So you've got 4 barriers, actually. But when we went on visits, for example, we went into Mombasa in East Africa for a visit when we were on our 9-month deployment out here. And we had a steam leak on the main steam range. And the rule is you are not allowed to do anything on board which might hazard your nuclear safety. Now, the steam leak was a nuisance because it made the atmosphere inside the maneuvering room hot and sticky, most unpleasant. But it meant shutting the reactor down and carrying out an isolation routine, in other words, a nuclear repair, effectively. And he said, no, we can't do that. The chance of an accident happening is very, very remote. It scared the daylights out of the electrical officer, who was a watchkeeper, because this plume of steam shot out from between his legs where he was sitting in the maneuvering room. I said, David, look, as long as you can see the steam, it's all right. It's the steam you can't see that's dangerous.
Right, Bob, have we still got
operation of the steam machinery? What happens if there's a leak inside the reactor compartment, a steam or water leak?
Right. You're talking about a reactor compartment entry. Well, it's funny enough that the usual reason for going into the reactor compartment, because there's an air treatment unit supplied with chilled water that kept the temperature in the reactor compartment at a reasonable level. And that was usually the main thing which didn't work for some reason. So you can do a reactor compartment entry around about half an hour after you shut the reactor down, providing you haven't been at too high a power previously. You need to brief the people. They need to know where the sources of radioactivity are, things like the coolant, various steam generators and various pieces in the reactor collect what's called crud. This is wear products which are activated. So they've got to keep out of the way. And there's also a maximum length of time they're allowed to stay there, a maximum dose they're allowed to pick up. And they carry with them a monitor which they can pick up every minute or so and just check to see what radiation they've actually picked up. And they have a film badge, which every month was returned as a classified radiation worker.
Yeah.
They send it in and it goes on their records. For legal reasons, later on, when you leave the Navy and your wife claims that you died of radiation received on board, they need some records.
So if you lose some light water in the reactor compartment, what means do you have for topping it up?
On the after bulkhead of the reactor compartment, all the services, high pressure air, dosing, injecting hydrogen actually. You inject hydrogen to prevent suppression of oxygen by dissociating the water. In the tunnel, and I didn't mention this, there is a tunnel from forward to aft, because through these two bulkheads, and in the tunnel there is a sampling station, because every 24 hours you take a sample of the primary water, checking for dissolved solids, gases, radiation to check. It's like taking the oil, an oil sample from your car. You can learn an awful lot from that.
I think it's a wonderful presentation. Thanks, John. Really was so much in it. A highlight of the year, I think, of our Zoom programs. And look, really appreciate it. Thank you very, very much.
Well, thank you, David, for that. Yeah, I did add in a bit more about the AUKUS. That's going to run a long while, I think.
It's formidable thinking ahead of what we've got to do. It really is.
But if it's achieved within a reasonable timescale, it'll be fantastic. It's only a small number of countries, an elite group who operate nuclear submarines.
We've been honoured to be invited. We really have.
Yes.
Absolutely. Fantastic.
To that.
Chiming in from this side of the Tasman, thank you very much indeed. Very interesting. I've got some reading to do, because in this latest copy of the British Naval Review, there's an article here on the AUKUS partnership and its implications. But I'd like to congratulate Australians in general for a very courageous decision, and I wish you all the best of good fortune for the fulfillment of this program.
Okay.
Thank you, Tony. And thanks for that.
Okay.
And if everybody does have a chance to look at this BAE YouTube video, it's well worth looking at. That gives you a very good understanding of what we're in for in building these submarines. Shouldn't be underestimated.